All right, here we go. Last video before Easter break. Man, that sounds like a plan to me. All right, so theorem 1.4. What happens when we have to find the length of the segments that are going on here? This is section 10.6. So when you have two chords, it's called the chord-chord power theorem, okay? What you're going to do is you're going to multiply the two parts of the chord together. So notice how this chord AE is broken up into two parts. So we would take AC times CE, and that would equal BC times CD. Notice how BD is broken up into two parts, BC and CD. So again, that's AC times CE would equal BC times CD. Okay, chord. Next, theorem 1.5. What happens when you have two secants? Okay, so with the secants, if you notice this secant over here, it's broken down into two parts. You have an AB and a BC, and then this one is an AE and ED. Well, what happens is we're actually going to multiply the outside part AB times the whole segment AC. Same thing with the bottom secant. Outside part AE times the whole segment AD. So with the secant, AB outside times the whole segment AC, outside AE times the whole segment AD. AB times AC, AE times AD. Theorem 10.16, secant and a tangent. Now what happens? Well, the secant, we already talked about that. Same rule applies. Outside AB times the whole thing, AC. Now with the tangent, you just square it. That's it. AD times itself. So it's outside AB times the whole segment, AC, equals the tangent all squared. That's the secant tangent power theorem. So if we're going to talk about this again, when it's a chord, you just multiply both parts. Okay? When it's a secant, outside times the whole segment. Tangent, just square it. Chord, multiply both parts. Secant, outside times the whole segment. Tangent, square it. Okay, we're going to do a bunch of different ones from this packet today because there's a lot of them to do. So we'll do about 5 or 6 examples. So let's start with number 4. We need to find all of AB and all of ED. So we got two chords. Remember what we do with the chords. We multiply the two parts. So I'm going to take x plus 5 and multiply that by 6. So that's 6 times x plus 5. And then that's going to equal these two parts multiplied together, which is just 12x. So distribute 6x plus 30. That's going to equal 12x. So we know then 30 is going to equal 6x. So x is 5. So then we have to put 5 back in for x's. So if I put a 5 in here for AB, 5 plus 5 is 10, plus 6 is 16. So AB is 16. If I put a 5 in here for ED, 12 plus 5 is 17. Now, number 10. We have two secants. So we're going to take the outside parts times the whole thing. Now, I'm going to warn you, this is where people usually make a big mistake here. So I'm going to take the outside part 8 up here at the top times the whole thing is x plus 3 plus the outside part. So that's not just x plus 3 with an 8. That's going to be x plus 11. Then that's going to equal outside part 10 times the whole thing is x minus 3 plus 10. So that's x plus 7. Okay? So that tells me then that this is going to be 8x plus 88 when I distribute. When I distribute here, 10x plus 70. So subtract 8x, subtract 70. 18 equals 2x, so x is 9. So now we got to put 9 back in. Well, if I put 9 up here, 9 plus 3 is 12, plus 8 tells me that RT is 20. When I put 9 in here, 9 minus 3 is 6 plus 10. So VT, or TV, whichever one you want to call it, is going to be 16. For 16, we have a tangent and a secant. Well, we know the secant is going to be the outside times the whole thing. 12 plus 15 is 27. That's going to equal PQ squared. So this is 324 equals PQ squared. And now we're going to take the square root of 324, which is actually going to be plus or minus 18 equals PQ. Now you got to put down that plus or minus 18 because you got to check. Maybe that negative 18 is going to work. In this case, it doesn't, because PQ is the entire side. We can't have that be negative 18. So PQ, which is what we're trying to find, equals 18. Okay, here's number 22. It's another chord one. The reason why I wanted to show you these next two is you might have to do some, well, factoring and foiling and all that good stuff. Okay, so it's a chord. So we're going to multiply the two parts of the chord. So for this one, it's x times 2x minus 1. And then for this one, it's x plus 2 times 2x minus 4. Okay, so let's distribute. 2x squared minus x equals, we have to FOIL now, okay? First, 2x squared. Outer, minus 4x. Inner, plus 4x. Last, minus 8. Well, notice what happens. These are like terms, but they cancel out. So what we have is we have 2x squared minus x equal 2x squared minus 8. Well, the 2x squareds actually cancel. So those of you freaking out right now because you see a 2x squared there, oh my God, Mr. Boyer, it's a 2x squared. Don't freak out. It's canceling out. Negative x equals negative 8, which means x is 8. Boom. Take a look now at 27. All right, tangent. I know tangent, we squared. Equals. Now here, outside, x minus 2 times the whole thing. Okay? Well, the whole thing is just 2x because it's x plus x, negative 2 plus 2. Okay? So x squared is going to equal, well, now we distribute, 2x squared minus 4x. All right? Well, here's what happens now. If I subtract x squared from both sides here, I have 0 equals x squared minus 4x. That's actually not too bad, because what I noticed then is I can take an x out, and that's going to leave me with x minus 4. So now both of these we set equal to 0 to see which one, or maybe both, is our answer. X equals 0, x equals 4. Well, let's check. If I put a 0 in here, I can't have a length of 0, so that doesn't work. But I can have a length of 4. Okay? So, there's your assignment. Page 199 to 200. You got to do 1 to 27. Okay? Now, there will be one problem where you have to actually factor. And you'll see it when it comes to it. Okay? So, I'll leave you with a little quote, one of my favorite quotes that I have. Actually keep these on my phone with me at all times. Good isn't good if it can be better. Better isn't better if it can be best. Wash your hands, save a life.